Welcome to Chapter 6.3a lesson on using proportions to find what we call the part. First of all, before we begin, this material right up here in this part of the lesson is extremely important. If you have a highlighter, I would suggest you highlight this. We are going to use that over and over again when we use proportions to solve these problems. Yes, we're right back to proportions again. Percent over 100 equals part over whole. You might even remember this from last year when I stressed it in our percent chapter. When we're talking about the part, it could be a tax, for example, a sales tax, or an income tax. It could also be interest rate, such as the interest rate on a credit card or on a savings account. The part can also be a discount. For example, perhaps they took off $12.50 from the price. That $12.50 will end up being a discount. Or it can be an amount of change. For example, if last year you made 1,400 items and this year you make 1,600 items, your amount of change is 200 items. Sometimes it can mean just a part of a group. For example, the percussionists of a band would be a part. The brass section of the band would be a part. The 8th graders, compared to the junior high, would be a part. The whole refers to a total amount. For example, using our band example again, all of the people in the band would be the total and the percussionist would be the part. All of the people in the band would be the total, but the brass section would be a part. All the students in junior high would be a whole or a total or a whole. The 8th graders would be a part. Now the whole can also stand for an original amount, and we use that a lot of times if we're dealing with calculating percent of change. The whole can also be an original price. Perhaps you're going to find out how much you pay for a pair of shoes that originally cost $175. Or a jacket that costs $225, or a car that costs $27,895. Let's look at some examples of problems and how they're going to be worded. Quite often you are going to find them written out, where they will say, find 45% of 32. Now this of not only means multiply. You could change 45%, for example, to a fraction and multiply by 32, but it's also a clue that the whole is coming next. So 32 is going to be the whole. Now you have to be careful because sometimes they'll flip that around and they'll say what is 45% of 32. So you might see it written that way. And sometimes you might actually see it changed in other ways. But for now, we're just going to be finding what we call the part. So you're mostly going to see them as either find 40%, 45% of 32, or you're going to say, or they're going to ask something about blank is 45% of 32. We're going to write out the proportion using that idea that I highlighted. You have the percent over the 100 and the part over the whole. I do not know the part because I have the percent, 45, which is 45 over 100. I have the whole, 32, so it goes into a denominator position. And I do not know the part. I cross product. 100 times n is 100n. 45 times 32 is 1,440. You have an equation formed here. 100n equals 1,440. See this? That's actually an equation. So to solve that, I'll take it back off. I am going to divide both sides by 100. That means I shift my decimal point over 2 places, and I get 14.4. All right, here's one where it says 80% of 62 is n. Again, this of says here's the whole. The whole is coming next. Is, by the way, means the part is coming next. So let's look at how we're going to set this up. We know the percent. Percent over 100 equals the part which I do not know of 62. Now personally, I like to reduce. I think it keeps your numbers smaller. You know the fraction for 80% if you've got your flashcard sheets. Otherwise, you can certainly reduce to get 4 over 5. The nice thing about reducing again is your numbers are a whole lot smaller. Cross product. 5 times n is 5n. 4 times 62. 4 times 2 is 8. 4 times 6 is 24. Now you have a one-step equation like we've been working with for quite a few years. So we are going to divide both sides by 5, and n will equal 49.6. Now C is a little tricky because we have a percent that is greater than 100. Now the problem is, people think, oh, I must have the wrong answer. Because when my percent is greater than a 100, my answer is going to be bigger than my whole. Here my whole is 46, my percent is 130. So I'm going to get an answer for a part that is bigger than 46, and that's not going to seem to make a lot of sense. But you got to remember this. When the percent is greater than 100, your part is greater than your whole. At this point, I would like for you to hit pause and you try this one. Okay, check your work. Did you get 59.8? That certainly is larger than 46. You got it right. Okay, yes, I can do this with story problems. About 40% of the students at a middle school participate in after-school programs. If there are 275 students at the school, how many students participate in the after-school programs? Now remember that we are working with that percent over 100 equals part over whole. So here it says ask yourself, when we do this mentally, I know that I'm supposed to have percent over 100. Do I know that percent? Yes, I do. It's 40%. Do I know the whole? Yes, I do. 275 students in the whole school. Do you know the part? No, I do not. I do not know the precise number of students who are participating in the after-school programs. So that means that's my variable n. Now I substitute into this percent over 100 equals part over whole. Percent is 40, so 40 over 100 equals, I don't know the part, over the whole of 275. Again, I'm going to reduce the 40 over 100 to 2/5. 5n. 275 and 275 is 550. And I kind of remember that because if I have $2.75 and another $2.75, I'm going to have $5.50. Then I can just take out the decimal point. Now look how nice of a division problem you have here. You're dividing by 5. 5 into 5 goes once. 5 into 5 goes once. 5 into 0 goes 0. Need a label though. Look at my question. How many students? Right there. So there's my label. And that concludes Lesson 638. Catch you for the next one.